Look, thank you to BCGS, particularly Dennis, Ross and Ron for allowing our committee to present. And thank you to my committee for allowing me to present on their behalf and to my companies that I'm involved with. And so I guess I'm a novice I'm an old dog in the game of geophysics, but just as I'm about to retire, this really exciting new technologies of drones come along, which is a huge revolution. So as part of wanting to give back, I'm working with Ron and others on the committee to help put together these guidelines, because there's been some excellent presenters here today, and they're all a hard act to follow. So I hope these guidelines, that can be a bit dry, are useful. I think we have to think of guidelines as being a defence against the cowboys in our industry, because when you think about it, 67,000 drone pilots in Canada alone, and I'm not sure how many in Australia. If 1% of those decides that they want to buy a magnetometer or an EM system and become a contractor with no geophysics background, we've got probably 10 times, 6 to 10 times as many people that are attending this symposium today. And so it's very important that we have these guidelines. And I think about the whole day, it's really been about guidelines. And I was particularly touched by Alan Chapman's reference to the 5 pillars of innovation, service, safety, operations, and stakeholder engagement. This is really what guidelines are about. So I'm hoping that we can get the collaboration and input from a lot of the experts that have presented today. So let's move on quickly and talk about what we're going to talk about. Who are the question mark, should be committee, I beg your pardon. Motivation, why we're having guidelines, for philosophy and structure of the guidelines committee, magnetic guidelines, other sensors, and the future of our committee, and particularly how you can contribute. I should say this is an update of a talk which was given in the 2021 SEG drone workshop. So who are the committee? Well, it's a global committee, and you'll recognise quite a few of the names, some of whom are on this call and part of this symposium. And they're all of there's probably hundreds of years of experience here, and probably almost going on 100 years experience use of drones as well. So, in particular, it's an inter-society committee that has bypassed the bureaucracies of inter-society. It's taken a long time just for us to get the guidelines together, and it would take longer if we work through all the various societies. So these are the memberships of our committee, that the societies that are represented by the membership of our organisations. We'll be taking these guidelines back to committees like these. And we should do a big shout out for the companies that these people work for, because a lot of their IP they've shared from their experiences with their companies, and so I guess these people are virtual sponsors. So why guidelines? I've mentioned it in my introduction, but let's look at that in a bit of detail. So assuming there's, let's say, 600 people in Canada, but who potentially might want to be geophysical contractors. And that compares to the 60 contractor members of IAGSA, who are all reputable and so forth. So all of these new operators are going to be on a steep learning curve, and Michael pointed out his learning curve and to the position of excellence he's in today with Pioneer, the Pioneer company. So so we know that some bad data is collected in Australia alone. We estimate that half of the drone surveys that are being done for mining companies, particularly small miners, is bad data, and it couldn't go through all of the manipulations that Laura showed us with the operations on the gridded data. So we need to try and address this to stop the the rot, as it were, and the reputation on our industry. So all geophysics operators, they may have come from a ground magnetics background. Very few would have come from an airborne acquisition background, and they all need to understand the basics of good drone data acquisition, noise mitigation and reduction and processing. Bad data gives our industry and profession a name. Bad safety incidents by rogue operators may result in restrictions on the operation of responsible operators. And particularly, we need to make these guidelines available to clients so they know what is good data and what's bad data, and help write their specs better. So we need all the experienced operators who compete in the commercial sphere, but to collaborate in the guideline sphere. So standards are expensive and time consuming, and can take you know, five years or more. We've been almost 2 years with the guidelines, and just getting that initial template in place for the magnetics. We're a voluntary committee, and it provides interim order. The guidelines provide interim order and voluntary adoption. And the benefits of having good data, I don't have to explain those to you. The guidelines can be updated and incorporate continuous improvement. Even though we've been a little bit slow in getting these out, it's still a more nimble way compared to developing standards, and enables, I guess, optional approaches to be canvassed in the guidelines as well. If over time they're adopted, then maybe they can develop into standards. So if we look at the philosophy and structure of the guidelines committee, what we're trying to do here, it's primarily a primer on good practice with the relevant sensor. We're not looking to reinvent the wheel. We're embracing the ready-made and reference the available and rapidly proliferating literature. So we reference the standards and guidelines that are in place. We basically just, in some cases, just provide a checklist of where people should go to find out and learn more about what they need to know. We have to be mindful of drone safety standards and promulgate these in the guidelines. There'll be no endorsement of one product over the other. The initial guidelines probably won't have tables in them comparing different products, but we're hoping that that will encourage all of the service providers to provide honest information about their products so that we can put them in tables and people can do their own comparisons. Because it's a voluntary project, we're all busy people. The speed of guidelines development is sort of being overtaken as we speak, as it were, because of the rapid changes in what's happening in drone space. So we do welcome voluntary input to the committee. A lot of the talks that were given today could just, if be put on paper, would become a good part of a guideline document for the sensors that people were talking about. So I do hope that the service providers and presenters today might consider joining our committee. We would be most welcome. So the plan is to actually put this public draft out, progress reporting to the key geophysical societies and to the public, and eventually get the endorsement of those societies. And I mentioned some existing standards. The ASPRS has standards on digital geospatial data, which covers both LiDAR and photogrammetry. And GeoSurvey of Canada have put out, along with the Geoscience Australia, put out standards on airborne data acquisition and processing and quality assurance. And Amira just recently put out a report on the developing UAV sensor arrays, and that's well worth looking at the public document if you're not subscribing to that Amira my group research. In addition, I should say there's some good MDPI publications on drones, which I recommend to people. So the guidelines are going to cover a focus on sensors, magnetics, radiometrics, electromagnetics, a ground penetrating radar, recent new subcommittee. Jan Frankie is a committee of one at the moment, so I'm sure he'd welcome people to help him. And maybe we might look at gravity. And basically for each of these sensors, the guidelines are going to look at the basics of the method, bearing in mind that we'll be dealing with clients that don't know geophysics and maybe a lot of operators that don't know geophysics. So we'll cover the basics, the technologies, the alternate sensor types, look at the noise that comes from these systems and how we can minimize them, and then just general coverage of data quality implications, end products by application, processing levels, and a reference and bibliography. Sorry, I went backwards there. And there's another focus which is just on the platforms and the logistics of putting things together under the subject headings, for example, of survey planning, execution, positioning, drone mapping, safety, drone platforms, because drone mapping is important, because often before we do a low-level survey, it'd be good to have a much better terrain model and a more recent photo of the area before we actually put our valuable geophysical sensors there. So all of these things will be covered, and as I said, we won't write a tome about it, but if there's existing information, we'll refer readers to it. So we did hope to try and get it out in SAGEEP, but I think we must try and get it out for at least the SEG drone workshop in 2022 or the SEG Emerge conference. We believe that's achievable. If I look at the current document, these are the current headings, and there is probably, for every one of those headings, there's probably 3 or 4 subsections, which I haven't shown. Red indicates those that are being worked on still to a varying degrees. Some are almost complete, but some need a bit of work. And the black sections are ones that are more or less complete and ready for editing process. So just a very sort of a teaser about some examples. There's something like, at the moment, there's about a 50-page document, and there's about 30 illustrations of processes and data, good and bad data, and end products and so forth in the document. This is an example of survey data for a fluxgate sensor and the sort of noise that we have to deal with, and perhaps possible ways of dealing with it with filtering. And we initially thought that there would be 3 levels of mag survey. Just level 1, where you're just looking for abandoned oil wells. Level 2, geological and geotechnical mapping, and level 3, very high precision UXO and archaeological mapping applications. And what may happen is that people may only apply certain levels in that hierarchy of certain corrections in that hierarchy of corrections. So what we have here is on anomaly strength and a log scale here, and the sort of level of the corrections that are involved in relation to the different processes of correction and the different levels. Obviously, we want to have as much data done as Laura has illustrated with level 3 processing, so that we can do all those fantastic operations on the mag data. But it may not always happen, and we just bear in mind that it might be collected for oil well data, but someone later on might want to use it for geological purposes. So it's better to try and process everything at level 3 if we can. This is just a simplified flow chart of the processing, and I won't go into detail here. There will be a PDF copy that will be emailed to all members that have subscribed to this workshop. so you can go into a bit more of the detail there. But I should say that magnetic raw data here, Exhibit A, and then low pass and reduced to 20 hertz from the original 1000 hertz sampling in B, with the diurnal and IGF removal in C, and the full micro leveling in D. So other sensors and activities of the committee, once we have this template in place, the parallel, some of the subcommittees have been working away just gathering some information so that they can then adapt that template for the other sensors. And we have subcommittees on EM, radiometrics, GPR and gravity, and I'll use that template. Our frequency domain systems cover time domain and frequency domain and passive systems, drone radiometrics, the European and Canadian US systems. GPR systems, Jan has just joined our committee, but I'm sure he'll have some ideas about what this can cover. And maybe we'll go on to drone gravity and thermal hyperspectral imaging in the future. But there's plenty of openings on this committee, and if you've got interest in any of these, or to help us more to develop the magnetic guidelines, please contact us. So this is how you can help. Join the committee or a subcommittee, review the draft guidelines, send in your ideas to any of our committee, send in good examples. We're looking for good examples of noise processing workflows, process data, case studies, and they'll make their way into the guidelines with acknowledgement. And also we're looking for a good bibliography. So contact Ron or myself or any member of the committee. And I guess I'll leave it there once more with questions and discussions if we've got time. And this is again the members of our committee that you could get in touch with if you know these people personally. So thank you for your attention, and it's back to you, Ron.
Yeah, it's Dennis here, and thank you very much, Geoff. Round of applause for Geoff from Melbourne.
Thank you.